Okay, welcome America, welcome Selena Gomez, and welcome India to the live recording in Studio 202 of Pre-Calculus. We're gonna do problem number 2 on the same worksheet I hope to attach to this video. And it is, yeah, that's all. Okay, so
You said okay again.
America, I'm trying to start my videos without saying okay. I just did it again. It's a thing. You know, some people say 52 times when they're talking, or like this, like that, like this.
It could be your whole thing.
My thing is okay. I'm working on it, okay? I'm working on it. Okay, so, all right, so why this piecewise function, we've got y equals x plus 3 for x values less than or equal to 0. So we need this first graph over here for all these x values less than or equal to 0. Then the second graph, this is going to be y equals 3. That's a horizontal line at 3. We need that for x values between 0 and 2. And the third one, this is y equals 2x minus 1 for x values greater than 2. So we're going to have 3 separate graphs. Okay. So y equals x plus 3. Okay, how do I graph that? This is y equals, slope is 1, y-intercept is 3. So I'm going to start at my y-intercept. Slope is 1. Now I'm not going to go that direction because I don't need the graph over there. I only need this graph for x values less than or equal to 0. So from here, and you can, like I said earlier, you can plot points if you'd like, but I use slope and y-intercept. Less than or equal to 0, so that point is closed because we need that value, we need this equation for x values less than or equal to 0. How are we doing? Let's use a different color for the second one. Second one is y equals 3. Y equals 3 is a horizontal line at 3. We only need that graph between 0 and 2. And I've already marked that, between 0 and 2. And it's going to be open at 0, and it's going to be closed at 2. One, two, three. And the last one, in green, y equals 2x minus 1. If we were to graph that back from algebra 1, the y-intercept would be at minus 1, or negative 1, and the slope is 2. So I'm going to start there, okay? This is not going to be part of our graph because we only need this graph for x values greater than 2. But there's my y-intercept, my slope is 2. There we go. So we only need, again, we only need this graph for x values greater than 2. Pretend like that's straight. Oof. Any questions on that? Yeah.
Is the blue point open?
So the blue point is when we were graphing y equals 3, it's between from 0 to 2, and it's closed at 2, which is why I closed it there, okay? But what happens is some of these graphs, and not all of them, you include a point in one part of the graph, and then it's open for the other part of the graph. So when we're graphing the green part, we don't need this graph for x is greater than 2, but it's actually closed when we graph y equals 3 at the same location.
Okay.
It doesn't always happen that way.
Thank you.
In fact, I think in problem 3, since we've got a separation in the graph, we're going to have some closed points and some open points. That's just how that problem works out. All right, so evaluate the following. F of negative 1. So if we didn't have the graph, we could take a look at the graph, but if we had just our equation here, we were asked to evaluate f of negative 1. Which one are we gonna throw it into? X value of -1. Is that an X value that's less than or equal to 0? Is it between 0 and 2? Or is that X value greater than 2? -1. -1. That's an X value that's less than or equal to 0. So we're gonna plug in -1 into this first one. So it's gonna be -1 plus 3. So that's gonna be 2. And you can verify that on your graph here. F of -1 is 2. We're good. Now 1 is between 0 and 2. So that's just gonna be 3. There's nowhere to plug it in, it's constant. F of 1 is gonna be 3.